This video will explain how to write polynomial functions and models given a graph of a polynomial function or given a list of ordered pairs from a polynomial function. So we're going to first take a look at here, if you're given a graph, how you can use that information to write a polynomial function, and then we'll take a look at it in terms of, here's just a list of points. So if you look at the graph here, this is going to correspond to some of the examples here in your notes from section 5.7 here. Let's take a look at this first example. So you can see the graph passes through several clear, nice and easy zeros. You can see that it crosses through zeros of the following ordered pairs. We've got zeros at -4, 0, 1, 0, and 3, 0. What we're going to do first here is we're going to turn those zeros and write them as if they are factors. So that way we have kind of somewhere to go with this here. So if I have the fact that my zeros, remember, are x-intercepts, so they each equal x. So I'm going to go ahead and turn these into factors by moving x and the number to the same side of the equation. So I can write this out here as x plus 4 would give me a 0 of -4. X minus 1 gives me a 0 of +1. X minus 3 gives me a 0 of +3. Now, that's going to take care of a lot of the function itself here, but the only thing that we need to figure out here is what the a value is. And the a value is going to tell us how the graph opens up and down, how wide it gets, how narrow it gets, etc. So here's what we have so far. We know f of x, our function, is equal to whatever the width, the height, whatever you want to call it here, that a value, times those three factors. What we need to find to finish off this function is, what is that value of a? So we're going to go ahead here and figure out how to get that a. The way that we figure out a is we need to take a point that's not one of the zeros and plug it into the problem. So what we're going to do now is we are going to substitute an ordered pair that isn't a 0. Now, if you take a look at your graph here, there's a lot of ordered pairs that you could technically choose from. I'm going to go ahead and choose the one that's already nice and bolded out for us. You see me here highlighted in red. 0, -6. That is not a 0. That's a y-intercept. That's a different type of point. I'm going to go ahead and take that ordered pair and substitute it into my function. So we'll put -6 in where f of x is, because again, that's how we call, the fancy way we call y. We don't know what a is, and everywhere I see an x, I'm going to go plug in that 0. So you can see here how that substitutes in. And now it's just a matter of doing good order of operations here. So we've got three things in parentheses that need to be added and subtracted, and then all three of those values are going to need multiplied together. So what I end up here is a times 4 times -1 times -3. That ends up coming out to a +12a. So again, all I'm doing here is I'm just multiplying the results of all three sets of parentheses, put it in front of the a just because it looks a little cleaner. So again, 4 times -1 times -3 gets me that +12. Divide each side by 12. -6 over 12 is -1/2. And that's my a value. To write my final function, I go back to what I had in the previous step here where I had all the factors written out. I plug in what I know for a, which is -1/2. And I'm going to go ahead and just write these factors out and call it a day here and write that as my equation. You could distribute, like we talked about in the previous lesson, the x plus 4, x minus 1, x minus 3. You could try to distribute all that together, and that certainly wouldn't be wrong. I am perfectly fine, though, if you just leave this answer as is. So, given a graph, basically you're looking for what are the zeros. The zeros can then turn into your different factors, as you see in the early on step, but we need to know the a value. That's a little bit different than what you learned in the previous lesson. The a value always worked out to be 1. We know that's not always the case. There could be another number that's in front of the problem that's our leading coefficient that can affect how wide or narrow the graph is. So we have to go ahead and go find that. That's how you do it from a graph. Use the points, pull them off, and plug in from there. You'll see here on excuse me, you'll see here with the other example that I'm going to show, it's the exact same idea. The only difference is you don't have the visual, you're just given a list of points. So let's take a look here. Again, if you're using your notes to kind of compare this, let's take a look here at the last example here. So I give you a bunch of ordered pairs. So -2, 0, -1, 0, 0, -8, 2, 0. Basically what I want to do is this. I want to identify which ones are the zeros. So the ones that are my zeros are going to be my x-intercepts, aka y's got to be 0. So we've got 3 of them here once again. -2, 0, -1, 0, and 2, 0. Again, that means these each have to equal x. And that means we can turn them into factors. So -2, 0 can be represented by x plus 2. -1, 0 can be x plus 1. And 2, 0 would be x minus 2. Again, we don't know the a. And that's going to tell us how wide or narrow this graph will end up being. So we're going to go ahead. We used those 3 points already. These are done. Now we're going to go ahead and take this extra point here. That's not a 0. 0, -8, again, is a y-intercept. It's a different type of point. I'm going to go ahead and take that, plug it into our function. So -8 for f of x. 0 goes in for the regular x. And we go ahead and simplify from there. So we end up with 2 times 1 times -2, which means the right side is going to become -4a. Divide everything by -4. 2 is going to be equal to our a value, which means I have a final function. F of x is going to be equal to 2 times x plus 2 times x plus 1 times x minus 2. So again, what you're going to do here is identify the zeros, turn them into factors, take the point that's not a 0, plug it in so you can find the a value, and then write the equation with the a value and the factors that you already established. That's how you go ahead and write a polynomial function, given zeros, given another point, to go find the missing a value.